Hello all and welcome to this section of the unit where we are talking about hashing and the importance of hashing in computer forensics. What is hashing exactly? Hashing is a form of encryption. It's a one-way encryption, meaning that we can encrypt a file, folder, a drive, a volume, and we get an encrypted output that cannot be decrypted to go back to what we encrypted in the beginning. So it's a one-way encryption. How does that happen? We are implementing an algorithm that will take any input. The input can be a file and can be a folder or a whole drive. That would be the input for that algorithm. The output gonna be a fixed length value, a hexadecimal value that we're gonna get, and that length is according to what algorithm we're using. The kind of algorithms that we use in hashing are the MD5 algorithm and the SHA-1. These are the most used in computer forensics, and MD5, for example, stands for message digest, and the hash value that we're gonna get is 128 bits, which is 32 hexadecimal digits. The SHA-1, we get a little longer value, which is 160 bits, that is 40 hexadecimal digits. If we want to go even safer, we can go to a longer values, which means that the algorithm is much safer against collisions that I'm going to talk about a little later here, and it is more secure, so collisions will be almost impossible to happen. So why do we use hashes in computer forensics? If I take two different files and I hash them, the value of the hash gonna be different from one file to the other. If I take the same file, hash it, and then do even one change of one bit on that file, the value that I'm gonna get gonna be totally and radically different in those cases. In forensics, I want to verify that no changes were done to the original evidence that I got, and I want to be able to do that at any point that I'm asked to do it. It could be in court, where the other side gonna ask to prove that no changes were done. This is the main use that we use hashes for in forensics, and the other use is to discriminate against certain files. When we are analyzing, let's say, a hard drive of what's an average hard drive nowadays is like 250 or more, which means tens of thousands of files that you have on this hard drive. If you're looking for a certain thing, let's say an image that you know what is this image and you have a hash value of it, instead of analyzing the whole 250 gigs of data that you have on that drive, you can just run a quick check against the hashes of all the files that you have on that drive and find the one that you're looking for very quickly if it exists there. That's one kind of discrimination against the data that we have, that we are using the hash values for. The other kind is there are very well-known good files like system files that we can also get the values of those files and run them against our image that we are doing the analyzing on, and just exclude those very well good known files from our investigation, which will save us a lot of time. Some of the tools that we use for hashing, the MD5 sum and the SHA-1 sum, are two commands that are come native with any Linux distribution. You can use those just by typing the command itself, MD5 sum, and then the name of the file that you wanna run, that you wanna get a hash value for. HashCalc is a free tool that can hash files and files only. We will use that just to show you the effect of changing any changes that we do to a file, how it's going to change the value. And this is what we're going to use in the exercise that we will have in a second or two. MD5 deep and hash deep, another two tools that we can use to make not only on files, to make hashes not only in files but also on directories and on drives. There are many tools that are available out there. No matter what the tool that you are using, if you are using the same algorithm, if the algorithm that is used is MD5, no matter what the tool is, if the file did not change, the value of that algorithm, the value of that hash will be the same. So for this exercise, we will download a software called HashCalc, and the website to download that is from www.slavasoft.com. Before we do that, just let me say one word about hash collisions, because you've probably heard that MD5 was attacked in the past years and was successfully attacked actually, and it was proven that there are collisions on the MD5 algorithm. So what's a collision means? A collision means that if you have one file, you can create another file totally different that will produce the same exact hashing value. So in order to do that, you have to have control of the original file and the file that you are creating in order to get the same hash. In computer forensics, we're not going to be affected by this because usually nobody have control over the files that you have, and in order to create that collision, you need the third party need to be in control of both files. For our use, just to prove that there was no changes done on the file that we are producing as an evidence, then this problem of collisions will not happen. Add to that in most cases in computer forensics, we are using more than one algorithm to prove the validity of the files. We use MD5 and we use SHA-1. So as I said, for our exercise, we're gonna go to this website here, slavasoft.com, and download from the download pages. We will download HashCalc. So go ahead and download that. I already did that on my computer. Download and install it. Again, I did that already. Be doing with it. I'm going to double click it, open it, and as you see, I can use this software to hash a file or a text string or a hex string. We will use it to hash files. So here we're choosing file, and here we can choose which file we will be doing the hashing on. This is a list of all of the algorithms that this tool is using. We in computer forensics use usually either MD5 or SHA-1 to validate our evidence. Of course, we can use anything else from SHA-512 or any of the others, but MD5 and SHA-1 is the most used. You can go stronger than SHA-1, which is SHA-256 or 384 or 512, but for the needs of this exercise, we will use actually only the MD5 algorithm. MD5 stands for Message Digest 5. This is a hashing algorithm that will produce a 128-bit value for the file that we are hashing. For the exercise, we will create a file. Let's go with Notepad. This is a Notepad. I will create a file, a new file. I'll put any text inside it, something short for our purposes here. Call it this is a test, and save it. as test1 and save it on the desktop. Okay, save. Here we have it here. I'm gonna close it. Now using HashCalc, I will go to the file, choose the file itself. It is on the desktop in my case. I'm going to test1 and say open, and then hit calculate here to produce the hash. As you see, this is the hash value that we got. MD5, as I said, gonna produce a 128-bit value. 128-bit value is 16 bytes, which are 32 digits, 32 hexadecimal digits. So now we will copy the value here. We'll open another Notepad file, a new one, and we will paste the value that we got. Let's call it the original file and minimize. Now, in order to understand what hash is, we just created a value, a fingerprint if you want, of this file that I created. I will test now if I do any changes in this file, what will happen to the hash value. So let's go back to the original file I created, which is test1, and I will do a little change here, just add a dot in the end of the file, and then save it. And now I will recalculate the value. So it's the same file, test1, that I just did the change on and calculated the value, and I'll copy it and paste it on that Notepad just to see what the difference is. And I'll call that modified file. As you see, those two values are very, very different one from the other. Any change that we do to a file will produce a different value of the hash. That is what hash algorithm will do. If I go back to the file itself and undo the change that I did, which was adding just the dot in the end, I'm going to delete it, save the file, and run the calculation on it again. Copy it, and let's compare to what we had before. As you see, this value is identical to this value here. When we are doing hashing, the hash is done on the content of the file. Any changes whatsoever to the content of the file will change the hash value. Now that we got the file the same content that it was in the beginning, we got the exact same value. So hashing is repeatable, meaning if that file did not change, every time that I run the hash calculation on it will produce the same value, as long as we are using the same algorithm to calculate the hash. So now let's examine some other aspect of it. What will happen, I will call this again original. What will happen if I change something that is not in the content of the file? What if I change just the name of the file? If I open this file again and say save it as, and give it totally different name.
and save it. The content is the same. I did not change anything in the content, but I called it something else, and I will run now the hash on that. So I'm navigating to the hashes. I'm navigating to the desktop where the file is, and the file is different name. Open it and calculate the hash on it. Let's take that, copy it, and paste here again. As you see, it's the same exact value, identical. So changing the metadata of the file will not change the hash value, because a hash is done on the content of the file, not on anything else. Let's try the same thing with a different kind of file. Let's go with Word this time. I'll create a new file. This is a test. Save it as test2 under my desktop. Now run the hash again on it. We called it test2. Here it is. Calculate the value. I have to close it. Calculate the value. Oops, we got too many algorithms working here. We right now needing only the MD5. You can try it with the SHA-1 if you want. The differences between the MD5 and the SHA, of course, there are different algorithms, but the visible difference is the length of the hash value. You can see here in the SHA-1, the hash value is 160 bit as opposed to 120, which will make the hash algorithms more secure, much less collisions, which means if I take two different files, I will not get the same hash value. Back to our task. Let's lose this SHA-1 and we are back to MD5. I'm gonna copy it, go to my file where I'm recording the values. I'll paste it and we'll call it Word doc original. Now I will open it again and we'll do a change in it. Let's just go with changing one letter from lowercase to capital. Okay, and save it. And now I will run the calculation on it again. I have to close it in order to do that. And as you can clearly see, it's a very different number. Remember, the change that we did is just replacing a lowercase letter with an uppercase, with a capital letter. Let's call this modified. And let's open it again once more and change it back to what it was. Save it, close, and let's run the calculation on it again. And look what happened here. Is this value equal to this value? No, it's not. So your homework now is to explain why the Word document did not behave the same way that the Notepad document did, or that any actually other file will, by keeping the same value.